हेलो बच्चों। पिछले वीडियो में जब हमने एंगुलर मोमेंटम ऑफ सिस्टम ऑफ पार्टिकल्स की बात की थी तो वहां पर हमने आपको बताया था कि टॉर्क ड्यू टू इंटरनल फोर्सेस ऑफ सिस्टम ऑफ पार्टिकल्स इज जीरो। एंड हमने बोला था कि आई विल गिव द एक्सप्लेनेशन ऑफ दैट, हाउ इज इट जीरो। सो I have written torque due to internal forces in the system of particles. So I will give you the proof of it, how the torque due to internal forces on the system of particles is zero. Suppose we are considering three particles, and this is a three particle system. Suppose it is A, this is B, and this is C. Three particles. So what is internal force? Internal force is the gravitational force between the two particles. In between A and B, line joining these two particles, there will be force between these two particles, these two masses. Suppose it is F1 and this is F2. Likewise, force between A and C, B and C. I have taken three particles for my simplicity. Okay? So, suppose about this point, we have to find the torque due to these forces. Reference point is this. O is the reference point. Here, I will consider the position vector of these 2 points, A and B. Suppose this is R1 vector and this is R2 vector. And one thing we know, these forces they are in opposite direction, and therefore F1 vector is equal to minus F2 vector. By magnitude they are equal, so mod of F1 is equal to mod of F2, that is equal to, suppose I have taken, is equal to F. Now we have to find the torque due to these forces with reference to this point. See, if we extend this is direction of R1. If we extend this is the direction of R2. What is the angle between R1 and F1? This is the angle. And what is the angle between R2 and F2? That is, this is the angle. Okay? Now, we know tau, that is equal to R cross F. This is the standard formula. Now we will find out the torque due to this force F1 on the system of particles. I consider only two. Likewise, for these two can be done, for BC also we can think of. So I have taken A and B two particles, and I will show that torque due to these forces is equal to 0. How? So R cross F means this can be written as, therefore magnitude of this torque is R F sine theta 1. Right? I will extend this and I will draw perpendicular from this point, and this is N. So R cross F, of course F1. So by right hand rule, R cross F1, it is inside. So direction of tau 1, it is F1. Direction of tau 1 is inside. Very important. Direction of tau 1 is inside the loop. Right? Similarly, if you look at magnitude of this R1 is equal to what? Magnitude of R1, that is equal to, suppose it is R1. Right? So here magnitude of R1 in the sense, this implies I can write tau 1 is equal to R1 cross F1, and here I will R1 F1 sine theta 1. This angle is this angle is theta 1, so this will also be theta 1, and this length is R1, so R1 sine theta 1 is OM, right? So here we can write R1 sine theta 1 F1, and that is OM F1, because R1 sine theta 1 is OM. So we can write over here OM is equal to R1 sine theta 1. Now similarly, angle between R2 and F2. See, direction of tau 1 is inside and direction of tau 2 I will find out. So angle between R2 and F2 is this theta 2. So this angle is equal to 180 degree minus theta 2. Right? So here OM again in this triangle OBM. OBM, this is 90 degree. So R2, mod R2 is equal to R2, right? This is for tau 1, this is for tau 1, magnitude of this, therefore tau 1 is equal to OM into F1. First we got torque due to F1. Now torque due to F2, that is tau 2 is equal to R2 cross F2. Very important. R2 cross F2. See, R2, right hand rule, R2 cross F2, turning from R2 to F2. Direction of tau 2 is outside, direction of tau 1 is inside. So we can write the magnitude tau 2 is equal to R2 F2 sine of which angle? Angle between this, that is theta 2, sine theta 2, right? Angle between these two. So therefore R2 sine theta 2 into F2, that is tau 2. And what is R2 sine theta 2? We have to find out. See, very important. Magnitude of this is OB is R2, R2 is OB, and OM is equal to, we can see in this triangle OMB, this is right angle triangle. So OM is equal to R2 sine 180 minus theta 2, that is R2 sine 180 degree minus theta 2, and sine 180 minus theta 2 is equal to sine theta 2, that is R2 sine theta 2. OM is equal to this also, right? For OM, for R2 sine theta 2, I can write OM. Here R2 sine theta 2, we can write OM F2, tau 2, that is magnitude of torque due to F2 is this, right? By magnitude, mod of F1 is equal to mod of F2 is equal to F. So this we can write, F1 is the magnitude of F1, that we have denoted by this, implies tau 1 is equal to OM into F. Mod F1 is equal to mod F2 is equal to F, that I have written over here. Similarly here, tau 2 is equal to OM into F. What do we notice? That tau 1 is equal to tau 2. Here, tau 1 is equal to tau 2. But we have to take the vector sum. The direction of tau 1 is inside, direction of tau 2 is outside. Therefore, this is for magnitude, but tau 1 vector is equal to minus tau 2 vector. Because tau 1, R1 into F1 is inside, tau 2, R2 into F2 is outside. In the vector form if you write, then this will be opposite to each other. Therefore, we can write tau 1 plus tau 2, that is equal to 0. This only I wanted to tell you. A torque due to internal forces between the two particles. I have considered only two particles over here. So sum of the torque of internal force between these two particles is equal to 0. That I have proved over there. Similarly, if you are taking these two particles, again sum of the torques due to internal forces will again be 0, and for these two particles will also be 0. Number of particles may be there. I have chosen only two particles, and the internal force between these two particles will cause torque, reference to this point, and sum of the torques due to these forces is equal to 0. Any 2 points we are considering, torque between the internal forces will be 0. So n number of particles may be there. For all the pair of particles, total torque with respect to certain points will always be 0. That I wanted to communicate to you all. So children, I will stop over here. Next video will be some other bit I will consider, and I will proceed further. Till then, all the